Alright, so last video we looked at how to determine how many covalent bonds a non-metal atom will form. Remember, you start by drawing the Lewis structure, and then any unpaired electrons will be able to form a covalent bond, whether it's part of a single or double or even a triple bond. We're going to go into that later. For now, though, we are going to go into drawing covalent molecules. So molecules are just any compound where they're covalently bonded together. So covalent bonding, once again, only non-metals. So we're only working with, looking at my periodic table, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, possibly selenium, bromine, iodine. And when we start breaking rules, we can actually make some of the noble gases start to form bonds. But we're going to save that for later. For now, we're going to start with water. It's a chemical. It's a molecule that's found everywhere on Earth. It's in the air, it's in the ground, it's even frozen up at the poles, or sometimes in our freezers. Water's a covalent compound. The electrons of the hydrogen and the oxygen are being shared with each other. Now, we're going to need to go in and try to figure out just kind of what this molecule looks like. Shape is important for these things because it helps determine things like polarity. When we start talking about specific chemical processes, the shape's going to matter. Organic chemistry. Biology, the shape matters big time. So that's why in chemistry we're going to start learning shapes as well. Alright, so we got a formula up there, H2O. First thing, make sure everything's a non-metal. Hydrogen's a non-metal, despite the fact that it's found over on the far left side of the periodic table. Oxygen's also a non-metal. Now, before I start drawing this whole thing, I'm going to draw little representations of these things. So hydrogen. First thing I want to do is figure out how many bonds these things want. So nitrogen has one outer shell electron, has one unpaired electron, so that one electron will form a bond. So now I have oxygen. Oxygen's in column 6 outer shell electrons. So let's go 1, 2, 3, 4, 5, 6. All right, so looking at that oxygen, I'm hoping you can see that. 2 unpaired electrons. Oxygen wants 2 bonds. A couple ways you can do it. You can kind of start thinking this through, trying to figure it out without doing anything. One of the things I'll do from when I need to figure these out is I'll even write out every single atom. Since we have 2 hydrogens, I'll bring another hydrogen down, draw a line coming out from it. So now it's just a matter of connecting the lines. I need to make sure every line is connected to something. I can't leave a line just hanging out there. So with it drawn like this, I could just connect that line there, connect that line to that line. I kind of know how this is starting to look now. The oxygen will need to be bonded to the 2 hydrogens, but I can't leave it like that. So because no bond can form a 90-degree angle. So if I want to draw this a little bit cleaner, oxygen there. Oxygen has those 2 pairs of electrons there. We have one bond to a hydrogen and another bond to a hydrogen. This actually helps us to see that hydrogen has, or water, has kind of this bent shape to it. So I'm looking at the hydrogens, and they kind of form this angle there. You have these 2 pairs of electrons here. When we start getting into polarity, that's going to be pretty important. Let's go through another example. Let's go through a pretty basic one at first. So let's go through NCl3. So the formula tells me I have 1 nitrogen, if I get out of the way, and I have 3 chlorine. So let's kind of do it the same way we did. Nitrogen, 5 outer shell electrons. So let's go 1, 2, 3, 4. Now I can double up 5. So nitrogen has these 3 unpaired electrons. Let's go ahead and draw bonds coming out of them, just so we know nitrogen's going to form those 3 bonds. Chlorine, I have 3 of them. So I'll actually even draw them out here. Chlorine has 7 outer shell electrons. So let's go 1, 2, 3, 4, 5, 6, 7. 1 unpaired electron. The thing about chlorines is they're all pretty much going to look the same. I'm hoping you can see that all right. My 3 chlorines all have 1 single bond coming out of them. Already, I can kind of start to piece this together. My nitrogen has those 3 single bonds coming out of it. I have 3 chlorines that each want a bond So if I'm doing it kind of the puzzle way, we can go there, just connecting lines, we can go there, and we can go there. So now I can't leave it like that. It's really messy and it doesn't tell me at all what the molecule looks like. But it does look like I'm going to have the nitrogen, which has a pair of electrons, 3 bonds, each going to its own chlorine. Now I can't stop there, because each chlorine has 3 pairs of electrons. And I can't just forget about them when I draw it down here. So each chlorine, I'm going to draw 3 pairs of electrons around each chlorine. Alright, so naming it is easy. This is just nitrogen trichloride. If the nitrogen was at the end, it'd be trichlorine monoxide. But the way that I have that formula there, that's what it would look like. So now let's start talking a little bit about multiple. No, we're going to leave that for later. Let's look at one of the things that we could start to do is we're going to start looking at multiple bonds between 2 atoms of the same element. So oxygen's kind of the one you can't live without. O2. I'm really hoping that's showing up. All right. So I have 2 oxygen molecules. Oxygen is in column 6, so 6 outer shell electrons. 1, 2, 3, 4. Let's go 5. And since I can rotate these a bit or flip them, I'm going to do it that way. This one, let's go 1, 2, 3, 4, 5, 6. Single electrons. All right. My 2 oxygens there. They each want 2 bonds. So to start off, I can connect those 2 lines together. Doing pretty well. These 2 lines here, they don't have to go to anything else. My formula tells me we only have the 2 oxygen atoms. 2 oxygen atoms. Let's just go ahead and connect those bonds together. Now, instead of having it look like a smiley face, I can actually draw this a little bit cleaner. So I got my 2 oxygen atoms. There's 2 bonds between them. So I'm just going to draw it like that. And each oxygen still has its pairs of electrons. And I'm going to spread them out a little bit. You wouldn't have to do that if you didn't want to, but you could. Spreading it out just kind of helps it resemble what it looks like in nature a little bit more. And not all of them, so we could also have, we're going to go with carbon with 3 chlorines and a fluorine on it, kind of back in the middle there. So let's start off with carbon. Carbon's in column 4, 4 unpaired electrons. None of them are paired. Carbon is the only element we know of that can form 4 covalent bonds, which makes it highly versatile. That's why when we look for signs of life on other planets, we look for carbon, because it's able to form compounds no other molecule can. It's pretty amazing, actually. All right, so carbon, once again, 4 covalent bonds. I have 3 chlorines. Let's go, I'm going to go over here. 3 chlorines and 1 fluorine. All right. So now my chlorines, once again, we know from before, we're going to have 7 outer shell electrons. So each one's going to have 3 pairs of electrons and want 1 bond. All right. This tells me all of this is 1 molecule. That means I have to have all 5 of these atoms all bonded together. That means I can't do something like that. If I do that, it leaves everything else out. If I do that and that, I'm now looking at 2 different things. And the formula tells me that's not what we're working with. We're working with 1 thing. Let's go ahead and get rid of that real quick. Chlorine a little bit hard to read. All right. So now same thing. I'm just going to start connecting lines. Since the carbon needs 4 different things bonded to it, I'm going to start just by keeping that refreshed. All right, let's just start connecting lines from the carbon. So this carbon here can go there, that carbon to that chlorine, there to there, and fluorine, out to the other side. It kind of looks like a spider. So we're going to have to redraw this. No bond's going to stretch that far or bend or anything like that. It looks like in the middle here, everything's bonded to the carbon. Put that in the middle. 4 bonds, each going to something else. Chlorine, 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 1 fluorine, chlorine, 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 1 fluorine. Now, I'm still not done with this thing. I have to include the pairs of electrons that the chlorines and the fluorine have. They each have 3. Alright, so that would be the molecule for that. To name it, I would call this carbon 3 chlorine, so trichlorine monofluoride, because there's only 1 fluorine. Alright, last time you did the first page of the packet, which is simply identifying how many bonds each of the nonmetals has. For today, you're going to work on the next 2 pages of the packet. You're really going to start drawing these molecules. 2 pages should be enough practice. That should bring us into the next class. We're going to start talking. There will be a video put up about multiple bonds shortly. With that, good luck.